Okay, well, hope everybody's doing okay today. We're going to continue with our lesson. We've pretty much got to the point where we can start getting through our strategy and sketching these graphs. I gave you a homework assignment yesterday. It's going to be due tomorrow. We should be able to get the majority of it done today, the lesson. And then tomorrow I'm thinking maybe the first half, go ahead, give you some time to also work on it just in case you may not be done. Maybe we can work a problem or two together. We'll grade it at the end of class, get that turned in. And then on Thursday, what's happening? We have our test. Okay, remember, you can always use your notes, but the exam is going to cover the law of sines, the law of cosines. Remember, we talked about how to find the area of those oblique triangles, say, for example, Heron's formula, that big radical expression. And then this material right here, sine and cosine. I'm sorry. Oh, yes, you can always use your notes. Absolutely. Okay. So I'm not going to be assigning any homework over the break. I mean, Friday when you come in, we'll go ahead and pass back the tests, talk about them if you have any questions, and that's going to be it. I mean, we will have a happy minutes, but besides that, we're probably going to have quite a bit of downtime on Friday, unless you guys want to move on.
No, we're good.
We'll see. We'll kind of see how that works out. Okay. But I think we're just going to end the week pretty easy. Go vacation, spend some time with family, get your battery recharged. We'll come back, and then we have about, 3.5, 4 weeks till Christmas? Okay, so it's going to be happening pretty quick. All right, I think that's everything I've got, unless anybody has any questions about what's coming up. All right, well, we were talking about sine and cosine. All right, well, with sine, see, we have a pattern of what we call critical values. We have a 0, maximum, 0, minimum, and then a 0. The period of sine is always 2 pi, and then we talked about several characteristics of it. Then we moved on to cosine, where he has his own critical values. Cosine always starts with a maximum, and I've even got them listed up here. Then a 0, minimum, 0, and then a maximum. Okay, and then we talked about some characteristics for that guy as well. And then we really started looking at the different parts of these graphs. The leading coefficient, what we call A, whenever we multiply against sine or cosine, we use that to find the amplitude. Remember, that's half the height of your wave. So the formula itself is really easy. It's just the absolute value of A. Should A be negative, that just results in a reflection, like we talked about yesterday. Okay, and then I believe we got through 4A, and we were just about to go ahead and start 4B. I think I ended giving you the formula for the period. Now, the period is how much space is needed in radians before the graph repeats itself, okay, over and over again. We call those repeating parts a cycle, okay? So the period, every time you see this, we're going to go ahead and say 2 pi divided by B. Now, if B is negative, again, that just results in a reflection, so we always want to use the positive version of B. Now, B is the coefficient of X. So if you're looking at these forms right here, we have A times the sine of BX or A cosine of BX. Whatever you're multiplying against X, that's your value of B. Whenever you're multiplying against A, or excuse me, against the trig function, that is A. All right, well, let's just get right back into this problem here, because I think we started it, but let's go ahead and just start from scratch. Let's say I want to go ahead and graph cosine of 1/2 x. Now, one thing that's going to be really important is being able to tell the difference between what's changing horizontally and what's changing vertically. And a really good indicator to help you with that is look for the parentheses. If there are parentheses, anything inside them is horizontal, anything outside is going to be vertical. So with both cosine and sine, we're going to go ahead and graph these using two ideas. First, we're going to start with a compound inequality. Okay, so I'm going to go ahead and put less than, equal to, less than, equal to. Now the compound inequality is always the same for sine and cosine. It never changes. I'm going to start with a lower boundary of 0 and an upper boundary of 2 pi. Always the same for sine and cosine because their periods are 2 pi. This is for 4b. Yeah, I'm just kind of writing that over to the side so I have a little bit of room. Okay. Now, whatever's in parentheses, whatever's happening horizontally, well, that's what's going to go in your compound inequality. So I'm going to put that x over 2, or the 1/2 x, right here in the middle. Okay, so the first part is to go ahead and simplify this compound inequality. I want just x in the middle. So how can I get rid of that 2? Yeah, just multiply the whole thing through by 2. Okay. So let's see. 2 times 0 will still give me 0. Less than or equal to, the 2's cancel. There's my x. Less than or equal to 4 pi. Okay, so I've got my compound inequality solved. That's always the first part. Okay. Now the second part is going to be to take a look at your critical values. All right. So let me go ahead and list my critical values here. Remember, how did cosine begin? Was he a 0 or a maximum? Remember, he was a maximum. So we have a maximum of 1. Then we have a 0. Then a what? Then cosine has a minimum. Then we have a 0. And then we go back up to a max. And kind of just think about graphically what would happen. You know, we're starting at a maximum. We go to 0, go to a minimum, back to 0, and then back up to a maximum again. Okay, we're just describing the vertical movement of this graph here. Okay, well, these are going to end up being your y values. Okay, so anything that's happening vertically outside the parentheses is what I want to affect these guys with. But you'll notice, is there anything outside the parentheses? No. So in this case, I am not touching those y values. They're going to stay exactly as they are. So now I got the y's ready to go. My x's are coming from the compound inequality. Whatever I end up with, the lower boundary after I simplify, I'm going to place him with the very first critical value. The upper boundary, I'm always going to place him with the last critical value. So see, what I'm doing is I'm creating ordered pairs for my transformed function. Points that would go on cosine of 1/2 x. Now, there's just one additional thing we need to do. I need to know these x's here, right? So there's 2 parts to this. First, you got to find the distance between your minimum and your maximum boundaries. So how far is it from 0 to 4 pi? 4, right? Okay, 4 pi. So from 0 to 4 pi, it's 4 pi units. Okay. Now, sometimes you may need to subtract if it's not 0 or something like that. But whatever that distance is, we are always, 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 always going to divide by 4. Okay, we want to separate our critical values by the same distance, and there's always going to be 4 of them. So you always divide by 4.
Yes.
Always. Okay, but what's 4 pi over 4? 1 pi. So this is what I'm going to start adding to my base value all the way up until I get to the top. So what's 0 plus pi? Pi. Plus pi. Plus pi. Now, this should always work. You should be able to add it one more time and get your upper boundary. What's 3 pi plus pi? 4 pi. See, it matches up. Now, if it doesn't match up, that means we made a mistake someplace and we got to go back. Okay. These are my x's. So I've created 5 ordered pairs on the graph that I'm trying to sketch. So, for example, the first ordered pair is this guy right here, just the first column. So that's just the ordered pair 0, 1. So I'm going to go 0, 1. Okay. The next ordered pair would be pi, 0, right? And you'll notice the grid's already ready for you. From the origin, I go pi to the right. 0 has me staying exactly where I am. What's the third ordered pair? Okay. So from the 0, 2 pi to the right, -1 down. Then we have 3 pi 0. And then we finish up with 4 pi 1. And there we go. Now you'll notice we have that curvy V, right? But what happened to it? It's stretched. Remember what we said yesterday? Whenever you multiply x by a number, you take the reciprocal. See, yesterday when we had 2 times x, the reciprocal is 1/2, right? So that graph was half of what he originally was. Well, here, what's the reciprocal of 1/2? Yeah, 2. So he's double the width he originally was. And there you go. That's it. Okay. We're going to be doing the same thing on all these graphs. Okay. So fill in the blank. Remember that the periods for each of these is going to be 2 pi over b. Okay. And remember, b is the coefficient of x. You just go ahead and plug that in. All right. Now, when it says here, compare and contrast, okay, well, let's say we have the value of b is greater than 1. Well, that's going to result in a horizontal shrink. Because, see, here we had 2. That's bigger than 1. So if b is bigger than 1, it shrinks it horizontally. What if b is less than 1 but greater than 0? Horizontal stretch. There we go. Horizontal stretch. Good, 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 good. So when you think period, you know, what's the period? What's the part that repeats over and over? Here's your formula, 2 pi over b. Okay. All right, let's try another one. Oh, sorry. Okie dokie. Ready to go? All right, now let's look at these. Phase shift. Well, a phase shift is just a fancy way of saying we're going to take the graph and shift it left or right. This is a left or right shift. Okay, but think back to Algebra 2 when you were taught these transformations. When you multiply by x, remember we had to take the reciprocal. What happens when you add or subtract? You take the opposite, yes. So here, when it says sine of x minus pi, this is actually going to push me right. It's going to take the whole graph and shift it to the right. So if it says x plus, then it's actually going to shift it to the left. The x values are always trickier than what we seem to think they would be. Okay. Now, let's just get right into it. Let me show you how to work. Okay. Whether it's a shift, we were just looking at a dilation, whether it's a reflection, all the steps to go ahead and graph these are the same. I'm always going to start with my compound inequality. So I'm going to say less than equal to, less than equal to. Now, for sine or cosine, remember we always put it between 0 and what? 2 pi. Now, what's going to go between them? There you go. Anything happening horizontally, anything in your parentheses. So in this case, it's x minus pi. Okay. Now, just like before, I want x by itself. So how do I do this? Yeah. So even though it's got 3 parts, whatever I do in the middle to get x by itself, I'm going to do to the other 2 parts. So I'm going to add pi here. I'm going to add pi here. So 0 plus pi, pi. Less than or equal to x, because those cancel. Less than or equal to what? 3 pi. Okay. All right. So right there, I'm done with my compound inequality. I'm going to take care of him in just a second. Is everybody okay with how I simplified him? Okay. Well, let's move on to my critical values. All right. What are the critical values for sine? Do we start at a 0 or a maximum? Okay, so sine starts at a 0. Then we go to a maximum. Then a 0. Then the minimum. And then back to 0. Because again, remember, we start at 0. Maximum, back to 0, minimum, and back up again, right? Okay, so we're kind of visualizing those y values as we go along. Okay, now here's my question. What's outside of the parentheses that's going to transform this vertically? Nothing. Okay, there is nothing in front of sine. There's nothing following the parentheses. So these guys, once again, they are staying the same. Okay, so how do I compare the x's I just got to these y values? How do I sync them up? Okay, so the lower boundary pi, we're going to put with the very first critical value, so pi 0. And Brandon says 3 pi, put him at the very end. Okay. Now, from pi to 3 pi, I want to divide that up into 4 equal spaces, because these graphs are always symmetrical, right? Okay. Well, first let's get that distance. How far is it from pi to 3 pi? It's 2 pi, right? And if you're ever not sure, just go ahead and subtract them. That'll give me 2 pi. So I know the distance I'm looking at is 2 pi, but what did I say a moment ago? We always, always, always divide by 4. So what is 2 pi over 4? Yeah, it's just 1/2 pi. Because the 2/4 will become 1/2, right? So it's just pi over 2. And you can use your unit circle to help you out with this one, like you're rotating around. If you're at pi, and I want to add pi over 2, well, what would that be? Okay, and not 2 pi. Let's say I'm at pi, and I want to go in and rotate pi over 2. Then you're at 3 pi over 2, right? Okay, so this would be 3 pi over 2. Now, plus pi over 2 again. Now it's what, Genevieve? Oh, we're close, but not quite yet. Okay, this would be 2 pi. Okay, because pi plus pi over 2 is 3 pi over 2. 3 pi over 2 plus pi over 2 is 2 pi. Now, Genevieve, 2 pi plus pi over 2, 5 pi over 2. And let's check it. Will 5 pi over 2 plus the pi over 2 once again, would that give me 3 pi? Yeah, because that would be 6 pi over 2. And 6 over 3 would give me or excuse me, 6 over 2 would give me the 3. Yes. My baby. Wait, was that mine or yours? Oh, it was yours? Oh, okay. I'm still concerned about it, but not as much. Okay. All right. All right. So has anybody got any questions on what I did? The compound inequality or your critical values? Okay. And how many points do I have on my graph now? 2. I got 5. Every column is going to be an ordered pair. Remember, the top row is the x's, the bottom row is your y's. So I have the first ordered pair, pi, comma, 0. So from the origin, I'm going to go pi right, 0. Then I want 3 pi over 2. Well, 3 halves is 1.5, right? So I'm going to go 1.5 pi and then 1 up. Now what? Oh. Then we go 2 pi 0. Then we would have 5 pi over 2, negative 1. And then 3 pi 0. Okay. Now, was there a dilation here? Did it shrink? Didn't shrink. No. Because there's no dilation. We weren't multiplying either sine or x by anything. This is just a shift. It just looks smaller because of the way those axes are labeled. Okay. So here, when I connect them, does that look like sine? Yeah. Now, in fact, what if I want another version? Because this is just one period, right? Okay. So I could just go ahead and repeat this pattern over and over again. After this 0 would come a maximum, then a 0, then I'd go for another minimum, and I'm off the grid. So I'm going to go in the opposite direction. Minimum, 0, maximum, 0. See, once you have one period, you can just repeat those points and end up with, as many as you want. See, all I did was take the original graph and go ahead and shift him pi units to the right. In fact, if you want, I can go ahead and graph the original. Remember, sine always starts with a 0, maximum, 0, minimum, 0. So this in red is just sine of x. Okay. Well, if you go ahead and take a look, this point right here, this maximum, went pi units to the right to become that one. So every point just shifted over. Okay. Is this making sense? Anybody confused? Okay. So what would you expect to happen for cosine of x plus pi? Yeah, it's going to be the original graph. You're just shifted left. Okay. So now walk me through this one. If we're going to graph cosine or sine, we always start with what? The compound starts with the I. Inequality, okay. So I'm going to go ahead and say less than or equal to, less than or equal to. For both cosine and sine, does not matter. It's always 0 and 2 pi. Always, always. But this time, what's going to go in between? X plus pi. Whatever's in parentheses is going to go right here. X plus pi. Is everybody okay? Okay. So is everybody good with how we set it up? Now what? How do I get x by itself in the middle? I'm going to subtract pi. So minus pi, minus pi, minus pi. So what's 0 minus pi? Negative pi, less than or equal to, those pi's cancel, so x, less than or equal to pi. Okay. All right. So the compound inequality is done. I'm going to put him over to the side for just a second. Now what do I want to look at?
Now you want to see if it starts at a maximum or 0.
Okay, so the critical values. Okay. Now what are the critical values for cosine? So we start at a maximum, then a 0 minimum, 0 maximum. So once again, is there anything happening outside of the parentheses? I'm not adding anything, I'm not multiplying. So once again, these 5 are staying exactly as they are. Now, if there was anything outside the parentheses, I just apply those changes to those numbers. Okay? Now, how am I going to get my ordered pairs? How does this compound inequality help me?
You want to put the first one, the first interval, like this.
Okay, so Brandon says the first one, negative pi, put him with the very first number. Okay, so where am I going to put the other pi? With the very last one. Okay. Now, let's look at this graphically for a second. Here's negative pi. Here's pi. How far are they from each other? They're 2 pi away, right? So it's very important we know that distance. Okay. From negative pi to pi is 2 pi. We always do what? Always divide by 4. So this is like the previous one. This is going to simplify to pi over 2. Okay. Now, maybe you can use the graph to help you out. We're right here at negative pi, but I want to add pi over 2. So where would that put me? Oh. Well, think about it in terms of maybe just the coefficients. Maybe it's the pi that's throwing people off. I want negative 1 pi plus 1/2 pi. If it will let me draw this. Yeah, so what's negative 1 plus a half? So it's just 1/2 pi. Okay, but it's negative. Negative pi over 2, because the negative 1 is seemingly the larger value. Okay. Now, what's negative pi over 2 plus pi over 2? 0. And see, that's exactly what we get to right here. Now, what's 0 plus pi over 2? Pi over 2. Now, will pi over 2 plus pi over 2 give me pi? Yeah, 1/2 plus 1/2 will give me a full. I think that may be the only part of this where people are still a little shaky. Okay. But see, now what do we have? We have 5 ordered pairs on this transform function. So I know the first ordered pair would be at negative pi 1. So I'm going to go left pi, up 1. Then the next ordered pair is what? Negative pi over 2, 0. Then what's the third one? 0, negative 1. Then we have pi over 2, 0, and pi 1. There we go. So that would be 1 period of this. Okay. All right. And now if I wanted more, in like another period, I could just repeat that pattern of dots and sketch another one. But let me go ahead and show you this. In both examples, the phase shift is just pi. I shifted pi right, and then I shifted pi left. So this one has a formula as well. You take C and divide it by B. Okay. Now C is whatever you add or subtract to x. Remember, B is what you multiply by x. A is what you multiply against sine or cosine. C is what you add or subtract, and you know it's a shift because you're adding or subtracting. So let's revisit this problem. What is his period again? We're going from negative pi to pi. So his period is still 2 pi, right? Okay, well, let's go ahead and put it to the test. Okay, see, my A is outside here, if this will let me draw. B is the coefficient of x, and then C is what I go ahead and add or subtract there, right? Okay. Oh, I'm sorry, we're looking for the phase shift. Yeah, it's a Tuesday, I'm sorry. Okay, but all we shifted was just pi units, right?
Yeah.
How far are we going to shift? That's what this formula gives you. Well, C is pi over, what's the value of B?
1.
Yeah, 1. So what's pi divided by 1? Pi. See, all I did was shift pi units left. Okay. And then this here, when you fill in the blank, okay, remember for the x's, when you're adding or subtracting, you got to take the opposite. So if you see something in the form minus C, you know it's going to push the graph where? Positive, so it's going to go right. Okay. If you see bx plus c, we know it's going to go left. The only time you have to be careful about this is, again, if b is negative, then that actually changes the direction. Okay. Well, good. Good, good, good. Okay, and here's our last set. Okay. Now, let me ask you this right here. Sine of x plus 1, we're talking about the midline. Now, the midline is always the very middle of the graph horizontally. It always starts out to be the x-axis. The only thing that's going to change him is a vertical shift, if he's pushed up or if he's pushed down, right? Okay. Now, I'll show it to you. I'll just go ahead and show it to you right now. Let's go ahead and graph sine's parent. Remember, he starts at a 0, a maximum, a 0. Then we have a minimum, 0, right? And I can just repeat that pattern, dot, dot, dot. Okay, so here is what sine looks like. Okay, so the midline is just a line that goes straight through the middle of it. And we always write it as an equation. So right here, it's y equals 0. Okay. Well, now we know in this section that that plus 1 has to represent a vertical shift, right? The whole graph is just going up 1. But let's say I just gave this to you without telling you that. How would you know that plus 1 is vertical and not horizontal? That's exactly right. How was I say that again? There's no parentheses. If we wanted you to know that this is a horizontal shift, then parentheses would have been put around this to let us know we take the opposite. But the fact that there's no parentheses there tells me that this guy has to go up 1. Okay? So it's going to change our process just a little bit. Okay? Let's go ahead and start with the compound inequality, just like we always do. So I'm going to say less than or equal to, less than or equal to. What's my lower? 0. Upper? 2 pi. Every single time. That never changes. Now, what's going in between them? Well, now be careful. Is the plus 1 inside? Remember, because Alize said there was no what? No parentheses. So the only thing I have here is just x. Oh, what do you notice? Yeah. Isn't it already solved for x? So we can leave him alone. We don't have to do a thing. Now, let's go to your critical values. What are the critical values for sine? Remember, it was 0, 1, -1, and then 0, right? This is the first one where we have a transformation that's changing these. What's happening outside? Yeah, I'm just going to add 1. So every one of these y values, because it's not in parentheses, I'm going to add 1 here. So 0 plus 1 is 1. So all 3 of those become 1. 1 plus 1? 2. -1 plus 1? 0. So I did transform those critical values this time. Can't talk today. Okay. So sometimes you may or may not transform one and not the other. Sometimes you may transform both. It depends on what function you're given. But these are the y values I want to use. Is everybody okay with how I got it? Okay. Well, now, how do I hook my x's up with these now? What do I do? It's still the same. The lower boundary, I'm still going to put with the first one. The upper boundary, I'm going to put here, 2 pi. Now, how far a distance is it from 0 to 2 pi? 2 pi. And what do we always do with that distance? Always divide by 4. Now, these problems are kind of giving you a false idea. Is it pi over 2 that you're going to be adding every single time? No. It just happens that these problems turn out that way. Okay. So let's see. What's 0 plus pi over 2? Pi over 2. What's pi over 2 plus pi over 2? Yeah, that's 1 pi, right? That's half your revolution. What's pi over 2 plus pi? That's 3 pi over 2. Now let's check 3 pi over 2 plus 2 pi. 3 pi over 2 plus pi over 2. Will that give me 2 pi? Yes. And see, now we've got my ordered pairs. Okay. Now here's what's really cool about this. The original graph, what would you expect to happen? Every point just goes up 1, right? Okay. Well, let's take a look. 0, 1. Pi over 2, 2. Pi 1. 3 pi over 2, 0. And then 2 pi 1. What actually happened? The entire graph just got shifted up 1. So it does not matter what kind of transformation you have. This strategy will give you 5 points on a period. Will take care of anything you come across. How we doing? Does this transform your lives? Because it's a transformation. It's kind of a stretch, but I'm going to stand by it. Okay. All right. So thank you very much, guys.